Another key here as far as passwords is never, ever, ever send the password across the network unencrypted. It should be either in a hash format or in a strong encryption format if it's going to traverse the wire. Now the difference there, and this is very important from a standpoint of understanding security, is a hashed password isn't really the password. What it is, it's an algorithm that takes some set of data. It doesn't matter what it is. In this case, it's a password. You take some set of data and you run it through this algorithm that spits out a certain set of characters. And it's just some random, amount of characters. It looks totally random. But every time you take that password and you run it through that algorithm, you get the same set of random gobbledygook. So the advantage there is you can't take that random set of stuff. You can't turn it back into the password. You can't decrypt it, if you will, because it's not really an encryption technology. It's more of a meat grinder, if you will. You take a filet mignon, you stick it in the meat grinder, you end up with hamburger. You can't take the hamburger and turn it back into the filet. It doesn't work that way. It's a one-way hashing algorithm. As opposed to encryption, where I'm going to take something, encrypt it in such a way nobody can read it, send it across the network, and use a key to decrypt it to figure out what was actually placed in it. There's the difference. So in the case of passwords, usually because we know the password, it's something a user knows, we don't bother encrypting it. We just send the hash. That way, at the other side, the user types in the password. We run the same algorithm against the known password and come up with the same hash. We know that the user knew the password. Okay. Another important thing for passwords is that the users need to be changing these passwords on a regular basis. The longer the passwords are around, the more likely that they are to be broken. If a attacker gets a hold of the hash, eventually they could break it. Now, I did say that you can't take the hash and turn it back into the password. But what I could do is, since I know the algorithm is widely available, if I know the algorithm, I can try the letter A and try it against the algorithm and see if it matches your hash. If that doesn't match, I'll try the letter B, then C and D and so on. Eventually, I'll get to the point where I've found your password. Depends on the password strength, depends on the number of characters you've used, the length of it, and so on. But eventually, I'll find it. So if you require users to regularly change their passwords, they won't be broken as easily as possible. Also, you should avoid things like, as you see on the screen, password iteration. So, the user started with MyPass101, and then the next month they change it to MyPass102. That really isn't a good solution with respect to passwords, and you want to make sure that users aren't reusing passwords or doing simple iterations to change their password from month to month.